Hi everybody, Mr. Wyatt here, and today I'm going to be going through the review assignment. I'll go through each problem in the review assignment. I have two videos here. This first video I'm going to get through number 7, maybe number 8, and then the second video I'll finish the rest of the problems. So you can go and just find the specific problems where you're having difficulty and see a demonstration of how to do them correctly. That way you'll be better prepared for Wednesday's test. So let's look at number 1 in the review assignment. C minus 8 equals 25. We have to figure out what goes in place of the variable c. And we have options. C could be 17, it could be 28, it could be 33. Okay, and we see those choices here, 17, 18, and 23. And if none of the, 33, I should say. And if none of them work, we can mark none of the above. All right away, I know it won't be 17. How do I know that? Well, it can't be 17 because how could you take 17, subtract 8, and get 25? That can't happen. Our value for C has to be bigger than 25. Okay, so I don't even have to try the 17. Let's test 28. 28 minus 8. If you substitute 28 in, 28 minus 8 is exactly 20. We want it to equal 25. So 17 didn't work, 28 doesn't work. Our last option is 33. If it does not work, our answer will be none of the above. So let's substitute 33 in for C. What's 33 minus 8? Well, 8 from 3 would put me in the negatives. I don't want that to happen. And so what I'm going to do is make this 3 a 2, and this becomes 13. A little regrouping. All right, so 13 minus 8 is 5. And then we have a 2 here. 25 matches 25 here. So 33 works very well. 33 minus 8 does equal 25. So that's my answer. Some of you might be wondering, well, can't I just do the inverse operation and take 25 plus 8 and see what I get? Yes, you can do that. But the point on these is to see you can substitute the values in and test to see if they're true. On number 2, it's multiple choice as well, so you could do the same thing. Try each of these. Does 15 minus 13 equal 28? No, 15 minus 13 is 2. Will 41 minus 13 equal 28? Let's try it. 41 minus 13. Well, 3 from 1, that means we're going to have to regroup. This 4, we can make it a 3. This becomes 11. 11 minus 3 is 8. 3 minus 1 is 2. We have 28. Is that what we wanted? Yeah, we wanted it to equal 28. So F minus 13, 28 minus 13, I mean 41 minus 13 does equal 28. Now that I know it can't be 31. But just to prove it, let's see what happens when we subtract these. If you substituted 31 in here, 31 minus 13, again, I have to regroup here. So 3 becomes 2, this becomes 11. 11 minus 3 is 8. 2 minus 1 is 1. Well, that's 18 instead of 28. So yeah, that one didn't work. F does have to equal 41. All right, number 3. If 6 plus 2 equals 8, does 6 plus 2 plus 3 equal 8 plus 3? Well, what you could do is put a box around this and put a box around this here as well. And then I'll switch to red here. And let's see here, I have 6 plus 2 here on the left side of this equal sign. I have a 6 plus 2 over here on the left side of this equal sign. On the right side of the equal sign, it's equal to 8. Over here on the right side of the equal sign, I have an 8. So then I take a closer look and I recognize, wait a second. All that I'm doing here to each side of this equal sign is adding 3 here and adding 3 here. So if we add the same amount on both sides of the equal sign, remember you can do anything you want to an equation as long as you do the same thing on both sides. It's like a pan balance in science. You add 3 on one side, uh-oh, it's out of balance. Add 3 to the other side, woo, we're back in balance. Okay, so that's the addition property of equality. So yes, it does equal, it is still equal. Why? Because of the addition property of equality. So it's this choice right here. Yes, because of the addition property of equality. There are two other answer choices that have yes in them, but it isn't the commutative property or the associative property that's being shown here. It's the addition property of equality. These are demonstrating properties of equality. All right, number 4 is very similar. If 4 plus 6 equals 10, and it does, 4 plus 6 does equal 10, does 4 plus 6 times 3 equal 10? Times 3? Well, it looks like it will. But again, I can show I have this right here equation. I have this equation right here. In red, I can circle, well, what do I see here? I have 4 plus 6 here on the left side of this equal sign. I have 4 plus 6 here on the left side of this equal sign. And let's see, I have a 10 over here on the right of the equal sign. I have a 10 on the right of the equal sign here. So what's being done to each side of the equal sign here? Well, it looks like we're multiplying by 3 here, and we're multiplying by 3 here. And since we're multiplying both sides by the same thing, it will still be equal. So this is the multiplication property of equality. So yes, these are fine. It is still equal. They are still equal because of the multiplication property of equality. All right, number 5. Now we get to actually solve some equations. And I have 9z equals 63. It's going to be important that we show our work. Some of you might say, well, you know, this means 9 times z equals 63. So 9 times what is 63? Well, I know it's 7. Yeah, it does. 9 times 7 does equal 63. But how would I show my work? 9z equals 63. Well, to undo times, we do the inverse operation, which is to divide. I can divide this by 9. If you multiply by 9, then divide by 9, those cancel out. And 9 divided by 9 is 1. 1 times z is just 1z. What will that equal then? Well, if you were dividing the left side of the equation by 9, you'd better divide the right side of the equation by 9 as well. And 63 divided by 9 equals 7. 7 times 9 equals 63. So z equals 7, which is this last answer choice. All right, number 6, we have x minus 17 equals 13. So I'll just rewrite this, x minus 17 equals 13. Okay, so if I want to solve for x, if I want x to be all by itself, I need to get rid of minus 17. If we've subtracted 17, then to undo that, we would add 17. We can do anything we want in equations. But if I do something on the left side, I must do the same thing on the right side of the equal sign. So I'm going to add 17 over here also. Draw a line under the whole thing. And you know what? Minus 17 and plus 17, they undo each other. So now I have x all by itself on the left side of the equal sign. X equals 13 plus 17. 7 plus 3 is 10. Carry the 1. 1, 1, 1, that's 3. X equals 30. Is that one of my choices? Yes, it is right there. Okay, let's look at number 7. A divided by 2 equals 12. Normally, I don't like to see the division symbol used in equations, but that's okay. To undo that, we need to do the inverse, which is to multiply by 2. You know, if you divide something by 2 and then you turn around and multiply it by 2, you're going to be back to where you started, which in this case is just a. But if I do that, multiplying by 2 on the left side of the equal sign, I also have to do it on the right side of the equal sign. So these cancel out. A is by itself, and it equals 12 times 2, which is 24. Is that one of my answer choices? Bing, 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 bing. Yes, it is. So there's my answer for number 7. I'll do one more problem, and then we'll end this video, and we'll do the rest of the problems, numbers 9 through 15 in another video. All right, number 8, I have 8 plus n equals 25. Now, you could solve it the way it's written. You know, 8 is being added to n, so we could undo this by subtracting 8. But it might make more sense to some of you if I reverse these two numbers, or these two values, using the commutative property for addition, and just write n plus 8 equals 25. Okay, and then it's a little easier to see. Well, to undo adding 8, I can subtract 8. But if I subtract 8 on the left side of the equation, I'd better subtract 8 on the right side of the equation to keep the scale in balance. Plus 8 and minus 8 undo each other. So it's gone, and n is all by itself. And what does it equal? Well, 25 minus 8. Again, 8 from 5 would put me in the negatives. I don't want that to happen. So let's make this 2 a 1. 5 becomes 15. 15 minus 8 is 7. And then we have the 1 there. So n equals 17. Test it. Does 8 plus 17 equal 25? You could count up from 17, 18, 19, 20. That's 3. 25, that's 5 more. 5 and 3 is 8. So yeah, that works out. N is equal to 17. All right, that's it for this video. I will do numbers 9 through 15 in the next video. See you in a little bit.